Hi, today I'm going to explain the science behind some different salad toppings. So first I'm going to make poppy seed dressing, which is an emulsion. It's a vinaigrette, so it's an emulsion of oil and vinegar. And the vinegar is 95% water and about 5% acetic acid. So that's the hydrophilic or polar part of the emulsion, and then the oil is nonpolar or hydrophobic. So usually those two liquids wouldn't mix, they would be immiscible. But when we make the emulsion, they will mix, and the oil will be the continuous phase and the water will be the dispersed phase. Now the key ratio in this recipe is going to be 3:1 oil to water or vinegar. So in this recipe I'm going to use 2 cups of oil and 2/3 cup of vinegar. So if you think about that, 2 cups is 6/3 and 2/3 cup is 2/3, so that's a 3:1 ratio. So first of all, I have the 2/3 cup of vinegar in the blender along with about a 1/4 cup chopped onion. And to that I'm going to add 1.5 cups of sugar. So the sugar is there to kind of add some body to the dressing, and it's also for flavoring sweetness. And then I'm also adding 2 teaspoons of salt, kind of a key flavoring for the vinaigrette. The next ingredient is really important. It is mustard. I'm adding 1 teaspoon of mustard. Now mustard in this ingredient, in this dressing, is the emulsifier. So mustard seed, the mucilage of the hull, the mustard seed, contains different proteins that act as emulsifiers. Specifically, they are surfactants. So they have a hydrophilic head and a lipophilic tail. So that means that they can interact with both the oil and water, and they decrease some of the surface tension between the oil and water so that they will mix better and help form a more stable emulsion. So first I'm going to blend these ingredients together. You might want to get in there and make sure the sugar got mixed in. Okay, then I'm going to gradually add in the 2 cups of oil, just really slowly and blending. You'll add about a 1/4 cup at a time, or you can just kind of slowly drizzle it as you're blending. So the key of this is you're adding sheer force and power as you're adding the oil, so that mixing action is going to help break it down into smaller droplets and help disperse within the continuous phase. So that way your emulsion will be more stable. So I'm just going to start blending this. Okay, and then finally, since this is poppy seed dressing, I'm going to add in 2 teaspoons of poppy seeds, and I'll just blend those in real quick. Alright, now this dressing would have to be stored in the refrigerator, and it's probably best to shake it or stir it before each use, because the oil and vinegar probably will separate a little bit on storage, but that mustard emulsifier should help prevent some of that. So I've made the poppy seed dressing, and next I'm going to make some homemade croutons. So these are just some breadcrumbs that I'm going to coat with some melted butter, seasoned with a little salt and pepper, some parsley, garlic powder, and onion powder. And I'm just going to toss the bread into this butter, and then I'll bake it in the oven. So these are the bread crumbs now coated with butter and seasoning, and I'm just going to bake them in about a 300-degree oven for about 25 to 30 minutes so that they can brown. So you can see these are the croutons after they came out of the oven, and you can see that they're really nice and toasted and brown. They also have that toasted aroma and flavor. And these are all the result of the Maillard reaction, which is non-enzymatic browning. So the Maillard reaction is between the carbonyl group of a reducing sugar and the free amino group of amino acids. So the bread has flour, which contains amino acids. One example is lysine, which really helps to give the nice brown color. And the flour also has some simple sugars, reducing sugars like glucose. So the reaction occurred because the bread was in a 300-degree oven, and that's about the optimum temperature for the Maillard reaction. So it involves several complex steps, and as I said, the initial reaction was the condensation of the carbonyl group of the reducing sugar with the free amino group of the amino acid to form an N-glycosylamine compound. Then that underwent amidori rearrangement in the second step to form ketosamines. The following steps were some dehydration reactions of the intermediate products, and then a reaction called Strecker degradation. And then finally those intermediate products reacted to form various flavor and color compounds, brown pigments called melanoidins, and that's why you get the brown color. So that's how you get nice toasted croutons, just homemade at home. Recap today, first I showed how to make an emulsion, which was a water and oil emulsion or a vinaigrette of poppy seed dressing. And then I showed how to make homemade croutons, and I explained the Maillard reaction, which caused the browning and toasting of the croutons. So now these toppings can be used to make a salad.